Hi, everyone, and thank you for joining us. We're going to talk today. We're going to talk about how you can use AWS machine learning services to process your documents faster. I am Samir Karnik. I'm the product manager on Amazon Comprehend, which is our fully managed natural language processing service. And I'm joined by Jillian Armstrong, engineer with Liberty Mutual, and Dave McFadden, solutions engineer with Liberty Mutual. So I'm going to start off with a high-level introduction of a few AWS services and a couple that we'll focus on in this webinar, Amazon Comprehend and Textract. And then Jillian and Dave are going to show you how they're using these services for their specific use case at Liberty Mutual. At AWS, our mission is to put machine learning in the hands of every developer. So to that end, we have the broadest and most complete set of machine learning capabilities. So at the lowest end of the stack here, we have ML frameworks like TensorFlow, PyTorch, and MXNet, and infrastructure like Inferentia, GPUs, deep learning, AMIs, and containers. One level above that, we have Amazon SageMaker, which abstracts away a little bit and allows you to label data, pick your right model algorithms, train your models, as well as tune parameters, and a lot more. Today, we'll focus on the highest level of the stack here, which includes quite a few services. For example, you can use recognition for vision-based machine learning. You can use Lex for chatbots and Kendra for enterprise search. The two services we'll dive into today are also at this level, which is Amazon Comprehend. Amazon Comprehend abstracts away a few decisions so that you can focus on your use case. For example, you don't have to worry about which model architecture should I use, or how should I tune the parameters, or am I using the right instance types? Am I getting the best latency or throughput that I need? We take care of all of that under the hood so that you can focus on your application and how to solve your use case. Similarly, Textract does a lot more than OCR. It gives you key value pairs, it gives you handwriting recognition, table extractions, and more. And today, we look at how you can use these services to process your documents intelligently. So let's talk about IDP. We've spoken to a lot of customers, and we hear that billions of documents are created, and these documents can be physical in nature, right? Like these could be handwritten forms that are scanned, or they could be um, uh, um, electronic, right? These are forms that are filled out on a computer online by somebody, but they're in various formats, they're in various forms, and the information from these documents needs to be extracted into some structured form so that it can be used effectively in downstream applications. Today, organizations have trained experts to do exactly this, right? Bring that information out from letters or forms and put it into a structured form. Or there is some level of automation. A lot of this automation is rules based because it's easiest to get off the ground, or it's template based. So that works well for standard documents. But if that document changes even a little bit, that automation again requires some maintenance or an update to work seamlessly. So, for example, the kind of documents that most people are working with are like the example you see on the right here, structured documents. We're seeing here an employment application and a W-2, and organizations need to get information out of these forms like the first name, middle name, last name, the phone number or the address. And a lot of this information is presented in the form of key value pairs. Sometimes it's in tables. There's some logical grouping for information that's within these tables, and that relationship is also important in understanding what information is presented there. In other examples, we've seen very dense or semi-structured documents like the ones you see on the right here. So in this case, there is a natural language here. So, right, you need natural language based awareness of the information presented here. Regexes don't tend to work well here because information can show up in various different ways, and one regex might not capture all of it. Here, people are using NLP based models. They're using pre trained entity extraction to get information like people, dates, organizations, quantities, some PII as well. Or our customers have also asked us for custom entity models, right, that you can use to extract information that's unique to your organization or unique to your domain. And you have example documents, you have annotated data. You just want to do a one-click train and use a custom model to extract this information, as well as you want to classify these documents to understand what type of documents you're dealing with. Right? So both these use cases that we just saw can be solved using Amazon Textract as well as Amazon Comprehend. These two services are on the top layer of our stack, right? Textract can get information, can extract text and data from virtually any type of document. Right? It can be scanned, it can be in not perfect form, and it's able to recognize this information and extract it. Amazon Comprehend, as I said earlier, is fully managed. It provides NLP models in the form of simple APIs, so you don't have to be a machine learning expert. Any developer who knows how to use an API can now incorporate machine learning into their application. And then we're also going to talk about Amazon Augmented AI, which is our human in the loop service. So in those use cases where you need 100% perfect results, the low confidence output or the low confidence results from machine learning models can be sent to a human for validation or verification or just a quick correction as needed. So let's jump into Jillian's and Dave's use case and see how they're using these services at Liberty Mutual. All right, Jillian, over to you.
Thanks, Samir. So I'm Jillian, and Dave will be speaking to you in a few minutes. And we're solutions engineers at Liberty IT in Belfast, Northern Ireland. And our company has a sole focus in delivering world-class software and solutions for our parent company, Liberty Mutual, which is a large insurance company doing business around the globe. And you may think that most business in 2021 would be done via the web. But in lots of businesses, and definitely in insurance, a huge amount of transactions are still performed via paper, or at least the digital equivalent of it. PDFs, text documents, spreadsheets, images, scans. And in fact, we receive thousands of documents and emails from our customers every single day. And that's true across our entire value chain, right from quoting to claims management. And that means that millions of hours are spent by humans working for us, manually inputting that data into our business systems before it can be used. And also, because of the high effort, a lot of data is never fully collected or connected to related data in the organization. And this meant that if we could automate the data entry, we could massively improve efficiencies, allowing our employees to focus on more complex tasks and also ingest and connect more information than would have been previously possible. Now, the first step in that is just pure automation. No AI needed at this point. And the diagrams we'll walk through today have been simplified down to some core components and are just one part of a larger platform, but they do demonstrate some of the key considerations. And there are two parts to the automation here. Firstly, automated data ingestion. We want to ensure that any data, be that emails, documents, other, is automatically routed into the system as it arrives. This saves someone having to manually monitor mailboxes or file systems, and also removes the time spent manually saving off files, which takes longer than you think. Secondly, automated data extraction. We want to be able to pull as much information from the incoming data as possible and get it into business applications where someone can actually use it. And you'll notice Event Bridge here, and that's because we made this a fully event-driven system. Incoming data is an event we can pick up and act on. And when we've processed that data, we can also emit events that allow multiple systems to go and retrieve and use that processed data in whatever way they want, whether that's saving it, sending it for review, or using it in other downstream processes. Now, with automated data ingestion, we just bring in the data, for example, a PDF file, and save it off. In the automated data extraction phase, we want to do more than just save off the raw data. We want to tap into the valuable information that is within that data, replicating what a human would do when they look at and manually enter information about that email, form, picture, or whatever has been sent to us. And the simplest data to work with in automation is where we have machine-readable text. Word files, Excel, mini PDFs. And one of the most common things in this category are forms. So let's walk through some examples of how we would think about extracting information from a form that we had received, because we receive a lot of forms. Now you'll see an example form on the left and the extracted text on the right. And as long as we have some knowledge of the structure, we can just use this information directly. For instance, here we know that we have a label, and then on the next line, the value that goes with that label. That's a pretty simple pattern that we could use to parse the text, and would mean that we could take that text block and transform it into a tabular format that could be put into a database. And you'll see if we expand out that step function we had on the earlier diagram, that we just need a few steps. Some pre-processing to determine what type of file it is, some extraction logic to pull out the text block and parse it, and then any post-processing that we want for that particular type of data. And as we've mentioned before, the ultimate purpose of taking that raw data and moving it into structured information we can save in our databases is so that we can replicate what our employees were doing when they were typing it in, getting it into our business applications where we can use it in our insurance flows, like giving you a quote or processing your claim, which all sounds great. Except real insurance forms don't look like our nice initial example. Instead, we see that the layouts can be much more complicated. They're rarely straightforward lines with a label and a value. Instead, we see that labels are above or even below the value they refer to. Multiple pieces of information are on the same line, and we see a variety of formats within the same form. And although we could read the text from them, parsing it becomes much, much more complicated. And maintaining a set of rules that can transform any text block into structured information becomes untenable. And this is where we realized we needed more sophisticated ways of handling our documents. We needed to use some AI in our automation so that we could expand out to even more complex forms. And this is where Amazon Textract comes into the picture. Since we were using that step function to orchestrate our extraction, it was very easy for us to add in multiple methods for extracting and mapping the data, and then use that pre-processing logic to direct forms to the best extraction choice. So we can go ahead and choose between basic rule-based options, our own internal ML models, or any combination of services, both internal and external. And Textract is one of those services that we added to our platform to help accelerate our automated extraction needs. As Samir has called out, Textract offers a number of different features, and although it does do straight OCR of the text, the big win for us was the Textract Forms service, because this can extract key value pairs from a form rather than just the text. So for something like this slightly more complicated example, we see that Textract can identify each of the labels and its corresponding value regardless of the layout. And that makes mapping those values out into our business systems so much easier and allows us a much higher confidence in those extractions, as we aren't having to maintain complex rules about how to map any text blob into structured data. We just need to know the form labels that we're interested in. And Textract gives us this even when dealing with very complex forms. And of course, there is another really important reason that we need more options for extraction than relying on machine readable text. A lot of our forms are not machine readable. Many are scans or images, lots can be low quality, more than you think have handwriting. And initially we directed these through other means, or we just sent them straight for human processing. But then at the end of 2020, Techstract added in handwriting recognition. And because our system is flexible, we were now able to start directing handwritten forms through our Textract extraction option and being really impressed with the results. We haven't had to do any filtering based on form quality. We found that the service can handle all sorts of issues like the form being slanted or faded or crumpled. Now, it's not perfect. We still need to have a human review on those more challenging forms, but it does make it quicker and easier for those doing the input to have that initial extraction done. And if we think about how we as humans deal with unclear information, for instance, terrible handwriting, we rely on context and also being able to cross-reference other information. And a generic OCR service doesn't have that context or cross-reference generally built in. So it may initially seem like something that just isn't going to be part of an extraction like this. But actually, most of our data doesn't come in isolation. We don't need to only rely on the OCR of a single form. Files come to us already connected with other data that also arrives at the same time. If we look again at this diagram, we can see just that. Almost all of the forms we receive come in as email attachments. That means we have additional information that we can leverage to improve and increase the information that we can extract. And Dave is going to tell you more about that.
Thanks, Gillian. And as Gillian said, the email attachments are not going to be the only place we get information. An email might contain multiple attachments, but it also is information in the email body that we will want. Some of these emails are pretty straightforward, where it's a single email with no replies. However, we've got more complicated examples where the original request could include a trail of emails between the Liberty employee and the customer. For example, when additional information has been requested. However, for the purpose of this demonstration, we're focusing on the single email. The importance of the email content varies. The one thing we know with emails is that the text is completely unstructured. As humans reading this, we can clearly see the attachments, the subject line, and the email body. It's important that we add automated extraction for emails as well as for the forms. So we added a parallel flow that runs simultaneously, allowing us to extract forms and email data at the same time. There are a number of entities available in the email that we need to discover before we can successfully process the request. One of these being the email context. Liberty, like most companies, has customer mailboxes, and these mailboxes can be used by customers for any request, whether it be for a claim, feedback, or general query. So identifying the context to successfully extract the content is very important. The email could also contain additional information. Some structured forms will have pre-labeled fields. One of those fields might be address. There could still be additional fields not in that structured form, and the customer might still want to share these. So it's important that we can successfully extract these from the email body. And as humans, we're not perfect, and mistakes will definitely happen. This example shows how the form and the email may also have conflicting information. In this case, the claim number differs. If a human was processing this form, they might need to do manual searches against business systems to validate which claim number is correct. Doing this systematically is no different. We will want to extract the information and use a series of rules, lookups, and cleansing to accurately predict the values. We chose Amazon Comprehend as one of the methods that could help us to understand the unstructured text from an email. Out of the box, Comprehend provides the ability to identify entities such as people, places, dates, and locations. As you can see, by running the example email body against comprehend, a number of these entities are identified. Take quantity, for example. If we had performed classification on the email and had already identified this to be in the context of a claim, we could add additional business rules and successfully extract the quantity value from the email with very little effort. As we showed in our architecture diagram earlier, we have multiple extraction methods running in parallel. By having these running in parallel, we're helping to increase the overall accuracy. And if we look at the values specifically for the 3 date entities, we know from having context that they are for claim date, repair date, and address change date. It would be difficult to write business rules to identify what each of these dates meant. So to help increase the accuracy of the claim date extraction, we built a custom model using comprehend. To do this, we labeled a number of emails to create a new entity type called claim date. This essentially involved highlighting that entity a lot on production data. Amazon has a minimum requirement of 200 annotations per entity, and this is the minimum, so by annotating more, it's likely you'll get a more accurate result. Once these were successfully labeled, we could create our model using custom comprehend. There are a number of ways this model can be used. It can be done by creating a real-time endpoint, which would give you the results in a matter of seconds. However, this incurs a cost of roughly $40 per day. Alternatively, the model could be invoked asynchronously, which takes longer, but the user only gets charged for what they use. This can be done as part of a step function, for example, allowing the user to poll the job and check the result until they get a response. And this was the exact solution we picked for our specific use case. But since our system is flexible, we could have multiple models deployed using both techniques. So now, looking at our diagram again, you see we have 3 methods of extraction. We're using these to retrieve information from the email by using custom rules, comprehend NER, and comprehend custom. Using each of these will give us insights into each individual piece of data. The last step in our process is to consolidate all the insights we're extracting and create a combined packet that can be routed to business systems or sent to a human to help them make an informed decision. Using a combination of business rules and machine learning, we can successfully create a combined packet of information that came from multiple data sources. By layering the business rules on top of the extracted data, we can get higher accuracy. Along with the business rules, we can also cross-reference the extracted data points from our data sources to ensure that they match. For example, if we have extracted claim date from the email body and the form, and the values match, this helps to increase the overall accuracy of the field. But with a similar approach, if they don't match, we might need to refer this request for human intervention. The main aim of this platform is to bring a number of unstructured data sources and create a structured data source that we can use for analysis, data insights, and eventually have zero-touch processing for a request. And looking at where we are now, we have a complete serverless platform that is extensible and flexible, orchestrated with AWS services and using AWS machine learning services to help with the extraction of a number of key elements. By implementing this extraction process, it's helping us gain up to 40% efficiency and avoiding the slow data input that Gillian referred to earlier. We are also continually adding additional use cases to the platform from across the company, each providing unique challenges and opportunities to help us further enhance our platform. And finally, looking to the future, the platform is continually advancing, so we're using these learnings to evolve and improve the extraction methods, therefore improving the overall system. But we're also looking to expand to different data types and some ambitious use cases. That's a high-level overview of how we're using some of the Amazon ML services to enhance a complex intake process and decrease the number of manual hours spent inputting data. I'm going to pass it back to Samir.
Thank you, Gillian and Dave. That was really informative. For those of you who want to do something similar at your organization, there's a few ways to get started here and how we can help you get there. On the top left here, if you're interested in running a POC, we have a ready-to-use a quick solution called Document Understanding Solution. The link is provided here. If you need help, if you need to, you need help building a model, building out a reference architecture, whatever it might be, we also have the AWS Professional Services team that can help. We have a team of solutions architects. These are experts in AWS services. They can help you brainstorm, understand your use case, and also get you familiar with the various AWS services. There's a link there to contact them. And then, of course, you can always lean on your sales and account teams to help you build an intelligent document processing workflow with AWS. I hope this was useful for all of you. We had a lot of fun talking about it. And best of luck in your intelligent document processing adventures. Thank you.